Comfortable, I hope? Okay. Good. The graphing calculator let's see if I can somehow get the lighting here a little better. This thing. Not sure if that's going to work real well. I have an 83 plus right here. How many of you are not familiar with the TI graphing calculators? Okay, a few of you. Does everyone have one yet? Not yet? A couple of you. We do have some to rent. If you want to pay $20 for the term, it'll be charged to your college account. You can come to the Math Resource Center probably early this week, and you'll be able to rent one from us over there for $20 for the term. Okay. If you don't think you'll need it after this term. If you think you're going to be doing more math, applied math, which could be in business or science courses, then I would encourage you to get your own. And I've mentioned this earlier, the 83 plus, the 84 would be the preferred, or the 84 plus would be the preferred type of calculator for you to get. All of these 83s and 84s work similarly. Okay, so the calculator looks like this thing, and what I'm going to do is I'm going to wait until we're over in the other classroom on Wednesdays to do that. But we can use this calculator to graph. We could even do it, I'm not going to take the time right now, but we could actually go ahead and do what we just did on the board there with the graphing calculator. We can plot points, and we can have it draw a line between points as well. But that's actually going to take more time than it is for you to sit down with a piece of paper and do it. Okay? We're going to use the calculator to confirm our thinking, and here's one quick example. If you see right over here where my finger is, there's a square root key on the case of the calculator. We activate that by hitting this second key up here. I call that the shift key. And then I'm going to hit this, and I think I'm probably going to have to zoom in here more so we can see the screen real well. Here we go. I have the square root symbol up here, and then I'm going to punch in there 85. I'm going to use these parentheses keys that are on the calculator face. Close that and hit the enter, and there, that fits with our mental estimate, our prediction earlier, a little bigger than 9. Okay. Real simple. Okay. The nice thing about these calculators is we can get several lines worth of calculations on here at once, and we also, I'll show you later, we have a way that we can actually go back through the stack and look at previous calculations that you have done. We can go back through the stack. I'll just show you. And the way I do that is let's see, I go down here, I hit my shift key, and then down on the bottom, I hit my enter key down here on the bottom right. So I'm going to hit that combination, shift, enter, shift, enter, shift, enter, shift, enter, shift, enter. It's going back through things I did last spring. Look at that calculation. Oh, man, looks great to me. Okay, I'll just keep on going. Oh, there we go. Okay, now I'm going backwards through my stack from things I did last spring. Okay, there's a good one. Okay, so that's enough on the calculator today, and I'll just shut that thing off. In your textbook, the second section of the book here talks about intercepts, symmetry, and graphing certain kinds of equations. Intercepts. Okay, so let me spend a minute or two going ahead and talking about intercepts. Yes? Yeah. Oh, I'm sorry. Yeah. I'll tell you what, you're not going to need the overhead for right now today, but I'll make sure I shift that over for the future so you can see the overhead screen well. Okay. Let's go ahead and talk about intercepts. We have two things in math. What do we call them regarding intercepts when you draw something like back in your intermediate algebra background? What kind of intercepts? X-intercepts and Y-intercepts. Okay. We have X-intercepts and we have Y-intercepts. Okay. X-intercepts are oftentimes called zeros for a special kind of relationship. We'll talk about that probably later this week. Functions is what we're going to be talking about a lot in this course. So for something called functions that some of you are not real familiar with, x-intercepts are called zeros. So those words are used in math interchangeably. The y-intercept, oftentimes there's only going to be one y-intercept, and that's just what it's called, the y-intercept. Let's go back to this example we just did over here. We have our 2 points, our 2 sample points, and we have an x-intercept. Looks to me like it's right here, doesn't it? Right here at this location. That's your x-intercept or your 0. The reason it's called a 0 is because the x value is shown here. There's some x value there of that intercept, isn't there? Some non-zero value. And there, the y value, notice the output value is 0. That's the reason this kind of a point is called a 0, is because the output value takes on a 0 value. Okay. The y-intercept, which happens to be here, where this line hits the y-axis, it has an x value, an input value, left and right here, of 0, and then some associated y value. I'm just going to put a question mark there right now. Now, do you remember for this particular problem, if I draw a straight line between these points, do you remember how to figure out the exact locations of those 2 points, those x-intercept, that x-intercept and y-intercept? How many don't remember how to figure that out? Don't be shy. Just raise your hand. I don't either. It's been a long summer. Okay. All right. What skill do you need from your background to be able to find the exact value of those points? What skill? Yes.
Don't you need to know the equation of the line?
Yeah. You have to know the equation that describes this relationship between the output and the input. In other words, the equation of that line. And you remember doing that before, but you maybe forgot how. Okay? How many forgot how again? Don't be shy. Okay? Half the class at least. Okay? That's normal. We're going to go back through that quickly, probably on Thursday, or excuse me, Friday. Okay. So we'll go through that then. Let's talk about a couple other things for a minute. Let's talk about symmetry. We could have points that could exhibit y-axis symmetry. We could have points that exhibit x-axis symmetry. And we could have points that exhibit what's called origin symmetry. I want to illustrate this by example. Let me draw a simple sketch here, and let me put a point down here, say, over here at 5, 1. Let me use the same point down here 5, 1, and the same point down here, 5, 1. Okay. Now, based on the vocabulary that you see here, what point would you see that would exhibit y-axis symmetry to this point 5, 1? 5, would it be positive 5? Oh, it'd be a negative 5 to get it over here on the other side of the y-axis, right? Negative 5, 1. What changed between those 2 points? The x value changed. The x value changed. So if you had a point that was given to you in general as xy, its y-axis symmetry point would become, what changed? The x, right? To its opposite sign. It would become the opposite of that x value, still holding the same y value. You don't have to memorize this little algebra thing here. Think about it. Not too tough, is it? Not too tough. Let's come down here and look at a point exhibiting x-axis symmetry to this point 5, 1. Become 5, negative 1. Be sitting right down there, wouldn't it? 5, negative 1. And what you notice is that the original xy point, its symmetric point, is going to remain the same x reading, but the y value changes sign. Feeling good? Feeling good? Okay. Let's come down here and look at origin symmetry. Now, what does that mean? Anybody heard of that before? We'll just look at the vocabulary. What do you think it means? Yeah.
Does it mean that it's symmetrical, like, I forget the term of symmetry it is, but when you can slice it any way through the center or the midpoint, and it's symmetrical now?
That sounded pretty good. What if I use that idea we did earlier with that distance thing, right? If I come straight from that point, straight into the origin, and keep going in that same straight line out the other side, the same distance, I would end up down over here, wouldn't I? Right? That's the origin symmetric point. Got the idea? So you pass from the given point through the origin and out the other side, equidistance, and you end up down over here at a point that exhibits what reading? Negative 5, negative 1. So the point xy transforms itself to the opposite x reading, and at the same time, the y value becomes the opposite. Okay. Don't forget this, because we're going to expand on this idea pretty soon in a very useful, practical way. Feeling good? Okay. And we have 5 minutes or so left. I've covered actually quite a bit of basic territory today. Let's come back over here for a minute. And I want to point out something that the textbooks always do, but that you didn't see me do at all today, regarding the distance between the points. What do the textbooks have in them? Something you've seen this before back in intermediate algebra, you may have forgotten. They give you a formula, don't they? So, let me show you that distance formula. If you had 2 points in general, let's call it x1, y1, and another point x2, y2 with subscripts, and we want the distance between those points, you could imagine us laying those symbols in on these points that we used in our example. x1 here, y1 here, x2 here, y2 there. Well, what we are doing is we're finding the difference between the x coordinates and squaring them, and we're adding to it the difference in the y coordinates and squaring them, and then we square root that result. So without me going through every little detail of that, it looks like this. And you've seen it before, you may have forgotten it. It's the difference in the x coordinates squared plus the difference in the y coordinates squared. It's the sum of those square rooted. A suggestion: don't memorize this. Now that's rare when a math instructor says don't memorize it, right? Okay. Why am I suggesting you don't memorize it? Yeah. You are less likely to make a mistake. I've been teaching a long time. Matter of fact, I was a student for a long time also. Everybody screws this up with the arithmetic, because oftentimes you're subtracting a negative in here and you don't get that difference correct, or similarly over here. Notice how much easier and less likely to make a mistake it is by drawing this sketch and doing what you see me do here. I can see the vertical spread. I can see the horizontal spread. I'm not going to get tied up in a knot doing the arithmetic. Okay? The midpoint that we did earlier, I've erased it, but the midpoint coordinates, they give you a formula in the book that is the average of the x coordinates and the average of the y coordinates to yield the x and y coordinates of the midpoint. Just remember how you average two equal weighted test scores. It's a little easier. Okay, anybody have questions so far? Okay, we've covered, let me see if there's something in this business of graphing that I should say in the remaining couple minutes today. Covered the idea of symmetry. We're going to spend time with the graphing calculator tomorrow, as well as the Math Excel set up for you. Oh, some of you came in late. Please make sure you get the textbook that comes shrink wrapped, or purchase separately the Math Excel access code. You want to hold yours up in the air again, just for those who came in late. There's the textbook and the access code. Just lift that, show it. Okay. You want to bring that with you to class tomorrow. We're going to meet over in the math computer lab, room 2, building 16, room 222. Now, before we leave, I think I'm going to hold off in the interest of time until tomorrow to talk about solving equations using a graphing utility. Now that phrase, graphing utility, works. It's kind of an archaic term from the early 1980s when graphing calculators first came out. We just call them graphing calculators. They're very useful for doing many, many things. And that's a big part of this course. That's actually the reason you're paying for 5 credits, is because we have almost 5 contact hours in this course. And so that 5th hour is actually to help you learn the use of the technology, which is going to be your backup tool to confirm your work. You will not need to look at the answers in the back of the book if you learn how to use a graphing calculator to check your homework. Okay, I think that'll do it today. I checked roll already. If you came in late, see me. And we'll see you tomorrow over in the math building up in the computer lab.